Hi everyone, welcome back to eMath Tutoring. Today's lesson is on exponential equations. So for example, when you're asked to solve something like the following. Now if you have an equation in the following form, and you're asked to solve this equation, this is whenever you have numbers as your base and your variable as your exponent, that's an exponential equation. And if you have something like the following, and if you're asked to solve an equation like this, you can see right off the bat here that x equals 2, because we know that 2 to the power of 2 is equal to 4. 2 times 2 is equal to 4. 2 multiplied by itself equals 4. So over here we can right away, we can just look at this and see the solution, because 2 is a root of 4. And we can right away see that 2 to the power of 2 is equal to 4. Or if we had, say, 2 to the x equals 8, we would just say, okay, x equals 3. 2 to the power of 3, 2 times 2 times 2 is equal to 8. Or if we had 3 to the power of x equals 9, we would just say x equals 2. So for equations like that, it's obvious to see the answer. But when you have a situation like this, it's not obvious. The answer is not obvious. So in a situation like this, when you have an exponential equation, so that's when you have a number as your base and a variable as your exponent, and it's not obvious like these ones here, these equations, the solution is not obvious right off the bat by looking at it. In a situation like that, what you have to do is actually use logs to solve something like this, and that's the only way to solve it. So you're going to apply the logs to both sides of the equation, because whatever you do to one side, you have to do to the other side. So you take the log of both sides, and once you do that, you can now use the rules of logs to bring down this exponent. And at this point, we would just solve for x, so we would divide both sides of the equation by log of 2.48. So the one on this side would just cancel out, and then our final answer would be 3.5. Okay, so that is the only way that we could solve an equation in this form, an exponential equation. Okay, where the answer is not obvious just by looking at the question. So we can try a few other examples. Say we want to solve for x, and we had something like this: 5e to the 2x plus 5 is equal to 6. So in this case, we've got e. So when you see e, when you see e, my hint is you're going to use ln, not log. So you're going to use the natural logarithm, which is ln. Okay, so what you're going to do first is, now first of all, with this equation, what I can do is I can divide both sides by 5 first, and I get the equation in the form 6 over 5, so e to the 2x plus 5 is equal to 1.2. Now, to eliminate e, if I take the ln of e, that will just cancel this out. It will bring down the exponent, and the ln of e is just, it just cancels out. You should get it that it equals to 1. So what we're going to do in this case, so now in the other one we just had a number in x, but when we've got e to the power of x, you're always going to take the ln of both sides of the equation to solve something in that form. And when you do, using, so this actually just cancels out, and you end up with 2x plus 5 is equal to ln 1.2. Okay, so when I take the ln, I have to do it to both sides, and when I do that, the ln eliminates the e, and I just end up with the exponent. So 2x plus 5 is equal to ln of 1.2. And that, of course, is using the rules of lns. The reason for that is because we can just use the rules of, their lns are the natural logarithms, or they're log to the, ln is just log to the e. Oops. Ln is just log to the e. So that's just a side note. So when I take the ln of e, this exponent comes down, and then ln of e is just equal to 1. So it's log e to the e. Sorry, ln is equal to log of e. The little e, not log to the e, but log to the little base e. So ln is log, so when we have ln of e, that ln of e, where e is just a number, as you know in mathematics, okay? when you have ln of e, it's log e to the e, so that's why it ends up canceling out. Okay, so as you remember the rules of logs, whenever you've got the base and this part as the same, that will just cancel out and equal to 1. Okay, so that equals to 1. So here we end up with 2x plus 5, and then we're just solving for x. This is just a number you can plug into the calculator. So you will eventually get 2x is equal to ln 1.2 minus 5. X is equal to ln 1.2 minus 5 all over 2, and then x is just equal to negative 2.409 is your final answer. Okay, so this here cancels out. Okay, and that's your final answer there. So these are for questions where you just have them in this form, where you just have a number and a variable as your exponent. You're going to apply logs, but whenever you see e to the power of a variable, you are going to apply ln, which is the log e to the e. Sorry, log to the e, little e. So you're going to apply ln, and that's going to help you solve the equation to eliminate. And when you plug in ln over here, this part here, you just plug this into the calculator and you'll get a number for that, and that's how you'll get your final answer. Okay. If you have another exponential equation in this form, say you have, and you're asked to solve for x, solve the equation. So you have 3e to the x plus 2e to the negative x equals 4e to the x minus e to the negative x. So here, what you can do is just, first of all, okay, now what I would do first is I would first try to deal with this number here, the 4. So I'd bring the 4 in, 4e to the negative x, so it comes into both parts. And then I would try to collect like terms. So e to the x and e to the x are like terms. So I'm going to put them both on one side. I'm going to bring the 3 over here. I'm going to bring this over here because e to the negative x and e to the negative x are like terms. When I bring the 4 over, it does become a positive. It's a negative here. So as you know, when you bring something over to the other side of the equal sign, it changes signs. So over here, this is positive 3, so when I bring it over to the other side, it becomes negative 3. And now I've got like terms. So this is like with this, and e to the x is like with e to the x. So because these are like terms, I can go ahead and add them. So this becomes 6e to the negative x, and this just becomes e to the x. So now we can bring this over to this side. 0 is equal to e to the x minus 6e to the... So I didn't actually have to do that. I could have just brought everything over to the right side. Maybe that would have been a better way to just solve it. Just bring everything over to the right side and then collect like terms. And I would have just ended up with this anyway. Now over here, I'm going to factor out e to the negative x because it's the smaller of the two. It's smaller than e to the x. So e to the x divided by e to the negative x is e to the 2x. And then 6e to the x divided by e to the negative x is just 6. I'm just going to show you how I got that. So over here I factored out an e to the negative x. So e to the x divided by e to the negative x is e to the x minus negative x. And that's how you get e to the x plus x, which is e to the 2x. Okay, so that's how I got this part here. Now over here, we've got two solutions. So we've got 0 equals e to the negative x, and then we've got e to the 2x minus 6 equaling to 0. So we've got this, and we've got this. So now we're going to work with this one. So because, so this one's, okay, now let's see here. Now this one we're going to try to solve. So we can bring the 6 over to the other side. So we get e to the 2x, and then over here again, to solve something like this, you would take the ln of both sides. So ln 6 is equal to ln e to the 2x, and when I do that, using the rules of logs, this cancels, and I get ln of 6 equals 2x. X equals ln of 6 divided by 2, which is, gives me the answer of 0.8959. That would be your final answer. And then, so this here would be your solution, and this we would just disregard. We wouldn't go further with that. Yeah, because if we tried to solve this, it would not work. Ln of... Okay, and just give me a moment. Actually, yeah, so let's just continue, sorry. Okay, let's continue. All right, so let's do one more. So say we had e to the 2x minus 2e to the x minus 3 is equal to 0. Okay, now if you have something like this, you can try to factor it. This is a regular, quadratic equation. And it's easy to see it if you just say let a equal e to the x. So if I just let a equal e to the x, and I can see that I've got a squared minus 2a minus 3, an equation in this form, and then I can figure out how to factor that. So as you remember, when you have an equation in this form, you want to think of two numbers that add to the middle. So add to negative 2 and multiply it to negative 3. And those two numbers would be negative 3 and positive 1. So I'm going to just write this as a minus 3a plus 1. Okay, and then now I can just put that e to the x back in. So e to the x minus 3, e to the x plus 1, or I could have just gone straight from here to here. Depends if sometimes people find it easier to do substitution and then they can see better what they're dealing with, or you can just look at something like just this and say, wait a minute, this is just e to the x squared. So I'm just going to write what I'm saying here. So it's e to the x squared minus 2e to the x, like that's in brackets, minus 3 equals 0. So if you look at it this way, you can easily figure out that this just factors to this solution. Okay, so that's another way to go ahead and do it. So then, so e to the x minus 3 equals 0, so e to the x is equal to 3. So if I want to solve, and this is equal to e to the x is equal to negative 1, and this cannot be correct. This is not possible, so this is gone. That solution doesn't apply. We can't have an e to the power of anything being a negative number. So e to the x is equal to 3. So over here we just take the ln of both sides. So x is equal to ln of 3, which is equal to 1.1. That's your solution to this question. Okay. So when you draw exponential functions, you can see that they don't actually touch 0, and that's why in the previous example, when I was just showing you this one here, I just disregarded this solution because it's actually not possible either, okay? The line never touches 0. It approaches 0, but never actually touches 0. It also does not go into the negatives, so that one doesn't work either. So here, then we get 1.1, and we are done. So that's solving exponential equations. Yeah, so there's other forms of questions you could get, but these are, two main kinds are with e to the power of x, or variables, and then just a number to the power of a variable. Okay?